I'm going to talk about how refrigerator works, alright? How HOW, how REFRIZERATUR refrigerator works, alright? How refrigerator works, alright? So, first of all, this is a chamber inside our fridge. This is a chamber inside our fridge, and the temperature here is high. How to make this temperature, this chamber cold, alright? So, what we do is, we have ammonia, liquid ammonia here, liquid ammonia. So when we supply the liquid ammonia from a pipe, and when we reach here, what we do is we suddenly let this gas to expand by opening very small valve. All right, so when we open the small valve here, the gas suddenly expand, and when that gas expands, it becomes very cold. All right, so this gas here becomes very cold in this tube. You see that here we are getting the liquid ammonia, and this liquid ammonia, when it comes here, there is a very small valve. When we open this, the gas expands suddenly and it becomes very cold inside that pipe. This is very cold ammonia, the very cold ammonia gas. All right, when it is very cold, what happens is we have a lot of vegetable in this chamber here. This is refrigerator, we put vegetable here, and these are hot, right? So the heat transfer from this vegetable into this very cold ammonia, like this. The heat transfer into the cold ammonia from the vegetable, like this. When the heat goes inside, what happens is that this liquid gas, this liquid ammonia get evaporated. So now this liquid ammonia becomes vapor. You see that now this is vapor. So what we do is we apply the electricity here. So we have to apply the electricity, and we have to compress this gas. We have to supply the electricity and we have to compress this gas. This is now compressed gas, all right? So this is very hot, compressed gas, and it is very hot. Now we have to cool it in the pipe, like this. So when it goes to the room temperature, it start to cool and start to become liquid again. Now it becomes liquid again, it becomes liquid. Here you see that it becomes liquid, and we put back to the freezer, and it keeps doing work continuously. So here when this gas is cooled, it gives out the heat that we call QS. This is the heat given by this gas to the high temperature. High temperature means it's a room. Yeah, we have a room here, so the heat lost by this liquid to the room is QH. All right, and the heat absorbed by this liquid ammonia from this cold chamber is, let's say, this is QC, and amount of electricity we use here to compress this gas is W. We call it W. You see that? So this is a W, this is QS, and this is QC. So what is the efficiency of this or the benefit or the coefficient of performance of this fridge? So we calculate like this. All right, so the benefit, where do we get the benefit? Here or here? We got the benefit here. So the heat absorbed by this liquid from the chamber is QC. So the benefit is QC. So what is the benefit percent, right? So the percentage of the benefit that we call the coefficient of performance is the benefit, the heat absorbed from this fridge, divided by the investment, the work we invest here, the work. All right, so the work we invest, work means the electricity. So the work is given as, so that is QC. W is the difference of QH and QC according to the first law of thermodynamics. So QH minus QC is the W. So we can write QH minus the QC. All right, so this is how we calculate the coefficient of performance or the benefit of the the refrigerator. All right, so you can also write it in terms of the temperature if you are calculating the theoretical efficiency. All right, theoretical coefficient of performance, that would be QC would be TC, and QS would be TS, and minus QC would be TC. If you want to calculate the theoretical efficiency of a refrigerator, you just have to put the values, how much temperature you are having inside this cold chamber, and what is your room temperature. So TC divided by TS minus TC would be the theoretical efficiency of the refrigerator. But the real efficiency of the real refrigerator would be the QC, the heat absorbed inside the chamber and divided by the heat rejected in the room temperature minus the heat absorbed here. All right, so that's how we calculate the coefficient of performance of the refrigerator. All right, so that's the benefit percentage. Thank you very much.